Hey guys, welcome back to another episode of Cracking the Coding Interview, the #1 software book for all interviews and software programming in general. Today we're going to be solving one-way problem. This is a problem we've solved in the past using a bit vector, and this is our previous solution. However, today we're going to take a different approach and solve it differently. Feel free to pause the video to read through what the problem is asking for. I find the examples more descriptive. So given two words, S1 and S2, two strings, right? We want to return true if they are one edit away. And one edit meaning we're only allowed to make three operations: insert a character, remove a character, replace a character. Okay, so in this case, in this first example, to go from string 1 to string 2, all you have to do is just remove A. That's just one single edit, so we return true. In this example, to go from string 1 to string 2, all you have to do is remove S, just one edit, return true. In this, all you have to do is replace P with B to go from string 1 to string 2, we return true. However, in this last example, to go from string 1 to string 2, we need to replace P with B, one edit. Also need to replace L with K, two edits. So we return false because that takes two edits. Remember, we need one edit or zero edits. So if both strings are identical, we need to return true. Prefer to read through the hints, but without further ado, let's go into explaining the approach we're trying to take this time. So today's approach is going to be what I call the Levenshtine distance. It just shows the distance, how much change you need to make between two characters to make them the same. Okay, between two strings, how much difference there is. So in this case, let's take the first example. In the first example, we're given word 1 and word 2. Okay, word 1 is simply pale. Again, we're going to ignore case. And word 2 in the first example was PLE, plea. Let's assume it's just small cases. Okay, I'm gonna go ahead and write their indices here. Okay, this is index 0, index 1, index 2, and index 3. Okay, so string 1 has 4 items, string 2 has 3 items. Okay, so now to go from, again, the trick is we want to go from word 1 to word 2. So how do we do that? In this case, the first step is to iterate through the string. So now we're on this index. P and P are the same, so what do? We do nothing, we skip it. We move on to the next index. Next index, index 1, in string 1 is A, in string 2 is L. Those are different, so what can we do? In this case, there's three things we can do, just like the problem said. The problem says we're allowed to insert a character, remove a character, or replace a character. Just one of these actions at a time. So in the first instance, let's say we decided to go the replace route, or to remove route. We could remove the letter A from string 1, trying to get it to string 2. So in this case, if we went this route, what we will have left is the string PLE, which is exactly what we are looking for, right? Going from string 1 to string 2, okay? Which is one edit. But let's look at the other cases. B is the case where we insert the letter L. In this case, what do we have? We're gonna have PLALE. We just only made the string longer. Let's also look at the third case. What we could do, we could replace the letter A with the letter L. In this case, what would we have? We're gonna have PLLE, again, which is also not what we want. So obviously the most efficient out of these three is step 1, removing A. So we can return, since we only took one step, we return 1. It's one edit away, so we return true. Okay, let's take a second example, just to drive this home a little bit more. Second example, let's make word 1 equal pale. Again, we're ignoring case. Word 2 equals bake. Okay, this is the example where we did get false. Okay, this is this guy we're working on right now. As always, let's go ahead and write the indices. This is index 0, 1, 2, 3. Okay, so we start with our pointer right here. P and B, they are different, so obviously we have to make a move. So what do we want to do? All we have to do is we want to go from string word 1 to word 2, so we have to replace the letter P with the letter B. And what would that leave us with? So string 1 is going to become BALE, bale. Okay, this takes us to step 2. Okay, but not yet. So now we're on here. A and A is the same. What are we gonna do? We're just gonna skip to the next one. Now we're on L and K. So obviously we want to replace the letter L with the letter K. This is gonna give us bake. And then when we do move on to this one, to this last one, we see they're the same, and we're just gonna skip. So here it took us 2 moves to get to where we wanted, so we return false. Okay, so now let's move from this. So now I've explained philosophically how it works, but let's move from the theory to the actual algorithm, what we're doing. To drive this algorithm home, I'm going to create a table, a simple table. Okay, and this table, the first item is going to be an empty string. Then the next item is going to be the letters of word 2. So in this case, we're going to use the first example for this table. So it's going to be a P and a, I'm sorry, we're using word 2 for the columns of this table, PLE. Okay, this is word 2. Similarly, this is word 1. So I'm just going to say word 2. Okay, so here's going to be P and A and L and an E. My L looks like a E. Okay, and this is word 1. Okay, so now let's go ahead and draw out this table so it looks cleaner. Okay, we have our table. So now let's go and fill out our table based on the algorithm. Okay, to go from an empty string, in this case here we have an empty string. To go from an empty string to an empty string, what you need to do? Nothing. Just do nothing, because they're already equal, right? That's a 0, not a letter O. Okay, now to go from an empty string to the letter P, what do we do? Simple, just one operation, insert P. This is 1. To go from an empty string to the letter PL, what do we do? 2 operations. First insert P, then insert L. So this is 2. Now by extension, to go from an empty string to the letter PLE, 3 operations. Insert P first, then insert L next, and insert E next. 3. Okay, now let's do it for the rules too. To go from an empty string to the letter P, what do we need to do? Just insert P1. By extension, this is 2, this is 3, and this is 4, right? Because to go from an empty string to the letter PALE, you first need to insert P, then insert A, then insert L, then insert E. That's how you get 4. So now we're done with this, guys. Okay, now next, let's start filling in the tables. But before we do that, I want to draw a smaller table, which is a subsection of this table, just a 2x2 table. Okay, now say we had a number here. We're trying to find X. We want to know what X is, but we had numbers A, B, C here. A simple formula for this X based off the algorithm is X is simply equal to 1 plus, so this is number 1, plus the minimum of A, B, and C. Okay, that's formula. But this formula doesn't always hold. In some cases, there's some edge cases where it doesn't hold, and I'll show you what the edge cases are. So let's start with use this formula. Let's say to go from P to P, how many moves do we need, right? Since P equals P is 0. However, if we use this formula says take the minimum of A, B, C and add 1 to it. So the minimum of 1, 0, and 1, and add 1 is 0. Obviously, add 1 to 0, which is 1. So if we put 1 here, this will be incorrect, because to go from P to P, you literally need 0 moves. So here's the edge case. If this element is the same as the other elements we're looking at, all we do is we don't use this formula. This formula is not going to work. All we're going to do is we're going to drag down this. Does that make sense? So meaning, let me write it. If word 1 of I equals to word word 2 of J. Okay, so if I call this matrix dp, let me just call it dp. This means dp of I j is just going to be equal to dp of I minus 1 j minus 1. That's simply what we just did here, put into code. So we just copy this, so this will be 0. We only do this when these two are equal, otherwise we use the formula. Okay, so let's go. How can we move from P to PL? Obviously it's one move, just insert L, right? P, insert L, it becomes PL. But let's use the formula. The formula says minimum of A, B, C, obviously that's 0, plus 1, so this is 1. Okay, let's do the same for here. To move from P to PLE, obviously it's 2 moves, just add L and E, right? But the formula says minimum of A, B, C, which is 1, plus 1, which is 2. Okay, so now we're done with this part. So by extension, let's check out A. To move from PA to P, simply one move, right? Just delete A. Okay, but let's use the formula. The formula says minimum of A, B, C. Obviously the minimum is 0. 0 plus 1 is 1. By extension, to move from PA to PL, obviously it's one move, right? Just replace the A with the L, right? Simple. So formula says minimum of A, B, C, which is a 0 plus 1. This becomes a 1. In this case, to move from PA to PLE, I think it's 2 moves, right? Because you're gonna have to replace A with L first, and then you're gonna have to insert E. That's how you get it. So 2 moves. Formula says minimum of A, B, C. Okay, the minimum is 1, obviously. 1 plus 1 is 2. Okay. Now let's go to L. To move from PAL to P, obviously 2 moves, delete A and L. Okay, but let's use the formula. Minimum of A, B, C. The minimum is C. 1. Add 1 to that. This becomes 2. To move from PAL to PL, again, this is an edge case where L equals L. So what do we do in edge cases? In edge cases, we just simply copy the diagonal. We do this formula. We just simply copy this guy down here. So this is a 1, right? So now to move from PAL to PLE, all we have to do is replace A with L, 1 move, and then replace L with E, 2 moves, right? But again, let's go with the formula. Minimum of A, B, C is 1 plus 1, which is 2. Okay, now to move from PALE to just P, 3 moves, delete A, L, E, right? But let's use the formula. Okay, so minimum of this guys is 2. 2 plus 1 is 3. By extension, to move from PALE to PL, simply just delete A and E, 2 moves, but again, minimum of this guy plus 1. This is 2. Okay, and by extension, this is E and this is E. This is an edge case, so what do? We just copy this number 1. And keep in mind that this is our answer. We want to return this last guy, so our final answer is always going to be return dp, if this is our matrix, of -1, -1. Okay, which is pretty much the last guy in the matrix. Again, if he's 1, then it's 1 edited away. If it's anything else, if it's 1 or 0, it's 1 edited away. But if it's greater than 1, we return it false. Without further ado, let's put this algorithm into code. So like we said, we're gonna solve it using the Levenshtein distance algorithm we just developed. And let me just call this word 1 and word 2. But anyways, it doesn't matter what you call it, to be honest. So let's create our DP array, like we said, which, remember, our DP matrix is just this guy right here. We want to create him and initialize him to all 0 starting off. Okay, so we're gonna create him on the fly using a list comprehension. So let's first create our rows, our first row. So our first row is just 0 for, again, like I said, we're initializing to 0 for I in range. What range do we want to do? We want to do length of word 2 plus 1, and I'll tell you why it's word 2 plus 1. So it's word 2 because, remember, this column is word 2, and then the plus 1 is because we're also keeping account for the base case, which is an empty string. That's why the plus 1 is there. So word 2's length plus 1, 4. Okay, so now we have our first row, all the columns. So now we want to make all rows. So we're going to repeat this for j in range. What range? Length of word 1 plus 1. Okay, good. So now we should have our DP matrix. Okay, let's print it. Let's see what it looks like, just out of curiosity, to be honest. Okay, boom, here's our matrix, right? 1, 2, 3, 4, 5, 5. Because word 2 has 4, yeah. So this is pretty good. So yeah, I'm gonna comment this guy out. Let's keep going. So what do we want to do now? Let's iterate for I in range length word 1, again plus 1 because of the empty string. So this is a nested for loop. Okay, the range is it's gonna be pretty similar, but for word 2. So now this is to iterate through each of the elements in that. So what we're gonna say, if I equals 0, what do we want to do? We want to dp of I j equal j. Okay, this is simply taking account I equals 0 is this first column, right? dp of rj is just 0, 1, 2, 3, just equal the indices, right? The same case is going to hold for this column right here. Okay, this row is 0, 1, 2, 3, this row is 0, 1, 2, 3, 4. It's the same similar rule. Okay, we're going to do the same thing. We're going to say L if j equals 0. In this case, the dp of rj, okay, is going to be equal I, just like I showed you, I. Now L if, now we want to take into account the edge case we talked about here, this if statement where word 1 of I and word 2 of j are equal to each other, and we just copy the diagonal, we copy the previous diagonal guy. So how to represent him? If word, okay, 1 of I minus 1, actually I minus 1 because we extended the length of the, just because of the empty string we're taking account of, and word 2 of j minus 1. If these guys are equal, then dp of I j equals dp, again we're just going to copy the diagonals, I minus 1 j minus 1. Okay, simple. So now else case, which is the final case where we do the actual meat of potatoes, dp of I j is gonna be equal to 1 plus minimum of what? Okay, remember our minimum, 1 plus minimum of a, b, c, where a is this guy, and this guy, a, b, c. So let's see how we represent it in code. So this is a, this is b, actually this is c, not b, and now this is c. Okay, that's it. So in the end, once we finish this, we want to return dp of -1, okay, the last element -1, but we don't want to return him. We want to check if he's equal to 1. So if he's less than or equal to 1, that's what we want to return. We want to return true. So this is a Boolean statement. If this element happens to be less than or equal to 1, this statement is going to be true, so we return true. Otherwise it's going to be false, we return false. And just out of curiosity, I just want to print, right before I return, I want to print the dp so we can see what he kind of looks like. So that's it for the code. Let's go ahead and run it and see. So this is false obviously because we need 2 and 2, and the last element in this dp is 2 obviously. But let's change this PALE to P, let's change it to S. Okay, obviously this should be true. See, the last element is 1 and we return true. So that's it for the video, guys. I hope this was helpful in showing you guys how to solve this problem dynamically. However, this is not efficient, right? Because this is a O of n squared, because we have a nested for loop. The previous way we solved it using just regular for loops was an O of n algorithm, which is faster. But again, you guys have a second tool in your toolbox to use whenever. That's it for the video. I'll see you in the next one.